Hi, good morning, everyone. So, during last class, we saw some defects of stoichiometry and non-stoichiometric defects. In that regard, we have saw some different stoichiometric defect like Schottky and Frankel, and a non-stoichiometry defect like metal excess and metal deficiency, and their causes also we saw. We left with one defect, that is impurity defect. So one type of defect is left with us, that is impurity defect. Impurity defect. So what is this? We will see, right? So impurity is nothing but already you know what is impure. That means if I add water, so if in water there is only a H and O, I mean H2 and O, then definitely that will be a pure. If I add some extra impurities, like we can say calcium, or chlorine molecule, chlorides, right? So hard water we can say. If I add impurities like this, then now this host will be a water only, but it is an impure. Why? Because there is no purity because of this, right? Calcium, like you can say anything, sulfate, sulfides, right? So if if a solid is made up of with say for example, generally I will take one example, that is stable salt, right? So Na plus Cl minus Cl minus Na plus Cl minus. If this was the case, that means this is a pure, what I can say, that a salt, pure salt, with no impurity. I mean, with no any other things are present. Purely it is a salt, that means a table salt. So if it undergo into the reaction, and in case of if this was happened, I mean Cr plus 2 Cl minus vacant Na plus Cl minus. See now, because to balance the charges, one Na will go off. Why? Because the foreign particle or the other particle which is not belong to this, right? So that means the impurity has came in this solid, right? In the form of what? Strontium, right? So if such thing happens in the solid, then definitely the type of defect is nothing but what? Impurity defect. Here what we did is we have added Sr plus 2 and we have removed Na plus, right? So to balance the ratio of charge, see there are 3 plus charge and 3 minus charge. Here also the same case, plus 3 charge and minus 3 charge. Because of the bigger molecule, that means the strontium with more oxidation number or positive charge, it has came into this solid crystal. So that's why the now the this sodium chloride table salt is impure. Before it was pure, but after undergoing into the reaction with strontium, then definitely the impurity will come. This is nothing but the impure salt, we can say. Actually a salt, the host is salt only, but because of other element has came into it, I mean in its crystal, so that's why the impurity has came. When small amount of foreign substances is adding to a crystal, this is nothing but the foreign. For example, with respect to a sodium chloride or table salt, strontium is what? Foreign particle. If small amount of foreign particle is adding to a crystal, I mean this is a crystal, and we have added a small amount of strontium to this crystal. So that's why such type of defects are called as impure. Impure means there is no purity, 100%. It is not a NaCl now because of other foreign particle has came in its crystal, right? So such defects are called as impurity defects. Okay, so these are all about, I mean, defects in our solids, right? And these defects are very important. You go through thoroughly, as I have already given a notes to you, right? So go through those notes, and if any doubts comes, definitely you can make a call, or else you can put a question in app, right? So there is no problem. So with these impurity defects, I mean defects are over. Later we will go to the next very important part, that is there are we have some what these conductors, semiconductors and all. So what I thought is later we will go for that, and meanwhile we will complete the semiconductors of two type, and which are very important, and they have asked in your main exam for many times. So those are these are also semiconductors only, but in semiconductors we have two types, right? Semiconductor, conductor. Later we will go. Already you know what are semiconductor and conductors, right? Or we will discuss that in next. Next very next class. So for this class we will go for the two type of semiconductors, N type and P type, right? N type of semiconductor, N type semiconductor, and one more is P type semiconductor, right? So first we will see what is N type and P type. Before going to this, N is nothing but negative charge, negative charge having semiconductor, and P is nothing but positively charged semiconductors. These concepts not yet completed in our offline classes. Please make your give your attention towards this, right? So these N type and P type of semiconductors are nothing but, N is nothing but negative. Negative means here one extra negative character will be there. If I take one example, then definitely you come to know. Say for example, these are also impurity type of defect only. So that's why what I thought is after completion this only we will go to the conductors, semiconductors and insulators, like, right? So take 14th group, right? 14th group is host means, right? 14th group means the valence shell electron will be 4, right? Like this. Silicon. We can take one example as silicon, and it comes under what 14 group. So silicon. So this is the host. Actually, this is a one type of host, and in this, if I add just like an impurity, the 14th group element host, if we add, 15th group element, if I add 15th group impurity, we can say 15th group impurity like arsenic. You can take any one example of 15th group. See, before going to this side, see here. Actually, silicons are having each silicon present in this solid are having 4 bond around it, right? Each silicon, not only one silicon, all the silicon present in this solid are having 4 bond around them. That's why its valency is 4, right? We cannot show with the bond, it will be confusion for you. So that's why I have given a hint like this, right? Plus 4. That means this silicon is forming a 4 bond around it, and now it is a stable molecule, right? So we are going to define what is N type now. So if I add 14th group is host to this 14th group, if I add 15th group element, any element you can take, arsenic you will take, that will be very best example for you. Silicon, this is the host, I think, I mean, silicon, right? If I take arsenic, then we will later define it, silicon. So one impurity we have added, and you just see this impurity, very important. You just see this impurity. What happened is, now our host is very much stable with 4-4 bond around them. But now, because we have added one extra, one bigger molecule like 15, we have not added 14 group only. We have added 15 group, one impurity. So now what happens? One extra character has came. Actually, they are very well satisfied with what 4-4 bond. And now what we did, we have added an impurity to this host, and that impurity is carrying what? 5 charge. 5 charge means one extra character. Actually arsenic 5, and one extra electron will be remained. Why? Because its capacity is, the silicon capacity is to form 4 bond around it. But because we have added an arsenic whose oxidation number, valence shell electrons are 5, that means arsenic can form a 5 bond around it. So that's why what is happening is one extra electron is remaining like that only. So that's why negative character will come on this one extra negative character. Otherwise, it was very much stable before. Because of this one extra electron, right? Because of this one extra electron, now the electron density has increased. That means if I see this complete solid, then in this solid, what we can observe? One extra electron. Extra electron means negative charge. So that's why its name is N type, right? So now we can define it. If a 14th group host, or to the 14th group host, if we add 15th group element, then one extra electron will be released in that particular solid. So that's why these type of, why? Because of presence of one extra negative character, that's why this type of what semiconductors are called as N type of semiconductors, right? In class, during class, I will give again, we will repeat this again, and I will give notes also, right? For now, you just try to understand what are these. If you come to know what is the concept, no problem to understand the concepts. So now we will see one more, that is P type. So P type means what I said, positive, right? P is nothing but positive type of semiconductor. So now again you take a 14 group host only, so that will be very easy for you, and add 13 group element. 14 group host, we will take silicon itself, so it will be very easy for you. Si plus 4 or Si plus 4. So this is the host again, same host. If we add a impurity like 13th group element, now what we are doing, to the 14th group host, we are adding what? 13 group elements, impurity. So 13 group means you can take aluminium, very best example. Silicon plus 4, silicon plus 4. Now silicon plus 4, Al plus 3, very important. Now we have to observe here now. Plus 4 again, Si plus 4, Si plus 4 and Si plus 4. So now see here, First of all, again the same host I took, that will be very easy for you. Now again the silicon is very well satisfied with its 4 bond around it. But now because we are adding 13th group element and whose oxidation number is plus 3. I mean it is carrying a 13 group element is nothing but plus 3. 14 means plus 4. So like now silicon requires what? 4 bonds around it. But what we did, we have added one less electron species, I mean impurity. So that's why what is happening, one bond is remaining because of what? Scarcity of electron. Now one bond is required to this silicon. It can form only 3 bonds. But this silicon will not form a bond with this. Why? Because here we are not having enough electrons. So we are shortage of one electron. So that's why what we can say, whenever there is a shortage of electron or when we undergo into the loss, then definitely what charge will come onto that particular element? Positive charge. In the same way, because we are having one less electron in this particular example or in this particular crystal, so that's why we are shortage of electrons. So that's why one we can say, what we can say, positive type of semiconductor. So this is all about p type and n type of semiconductors. In tomorrow's class, definitely I will go with the differences of p and n, and then later we will go for some concepts like you all already know those concepts. Why? Because these concepts will be repeated in your physics also. And then also we will go with our conductors, semiconductors, insulators, and band theory is also there for you. And then later we will see other part of this chapter, right? Thank you.